Section 7.5 is proportions in similar triangles. So, what is proportionality? Suppose that point P lies on segment GH and point Q lies on segment JK. If the ratio of GP to PH is equal to the ratio of JQ to QK, then we can say that segment GH and segment JK are divided proportionally. So what that means is, so GP is 3, PH is 6, and let's check if they're equal. JQ is 4, and QK is 8. So if we reduce both of those ratios, we get 1/2 equals 1/2. Therefore, we can say that GH and JK are divided proportionally because these are equal. So the triangle proportionality theorem, now that we know what proportional means, says if a line parallel to one side of a triangle intersects the other two sides, so for example, TU is parallel to one side of the triangle and it intersects these two sides of the triangle, then we know that it divides these two sides proportionally. So what that means is that the proportion of, so let me put this into symbols. In triangle QRS, if segment TU is parallel to segment QS, then, and this is what we looked at in the first example, the segments are just in different places, then we know that RT to TQ, so that's here and here, equals the ratio of RU to US. So that's here and here. But we have to know that TU is parallel to QS in order to know that that is true. So here we have DE is parallel to BA. Therefore, we know that CD to DB is equal to CE over EA. So it doesn't matter where you start when you set it up. I always just like to start with my variables. So we know that x to 12 equals 4 to 8. And then we can cross multiply to solve. So 8x equals 48. Divide both sides by 8. And we get x equals 6. So notice it's not the full side lengths of the triangle like we were doing in section 7.3. It's just x to 12 equals 4 to 8. So here, they gave us the whole length of side PS. It's 20, but that's not what we need to set up our proportion. We actually need to know the length of ST. So if the whole length of PS is 20 and PT is Y, then we want to take out this portion, right? We want to take out Y. So that means that ST is going to be 20 minus Y. So now we can set up a proportion. Y to 20 minus Y equals 3 to 9. So this is different than when we were setting up proportions for similar triangles. So make sure not to confuse the two. And now we can cross multiply to solve. So make sure you treat this like a group. So we have 9 times y is 9y, and then we have 3 times 20 minus y. Make sure you put that in parentheses so that you remember to distribute. 9y equals 60 minus 3y. I'm going to move all my variable terms to one side, so I'm going to add 3y to both sides, and we get 12y equals 60. Divide both sides by 12, and we get y equals 5. the tricky part here was coming up with the length of ST. And that was this whole length, and then we got rid of, so we subtracted the y, and that left me with the length of ST. So then we also have the converse of the triangle proportionality theorem, which says that if a line divides two sides of a triangle proportionally, then we know that it is parallel to the third side. So notice these are not marked parallel. We're going to show that if RT over TQ equals RU over US, then we can conclude that TU is parallel to QS. So remember, converse is when we switch the if and the then of a statement. So let's write that in symbols. So in triangle QRS, if RT to TQ equals RU to US, then we can say that TU is parallel to QS. So we just switched the QS. So we just switched the if and the then of the triangle proportionality theorem. So determine whether MN is parallel to GH. So we want to check the proportionality. So it doesn't matter what number you start with. 56 to 21. We want to check, does that equal 48 to 16? So reduce these if you can. 56 divided by 21 does reduce to 8 over 3. Because we can divide a 7 out of the top and the bottom. And then 48 divided by 16 is just 3. So this reduces to 3 over 1. Well, 8/3 does not equal 3. So since they're not proportional, that means that MN is not parallel to GH. Determine whether QR is parallel to ST. So we have to check the proportionality. So does 15 to 21 equal 17 to 23? Well, 17 is prime, so 17 over 23 doesn't reduce, and 15 over 21 does not reduce either. So 15 over 21 is not equal to 17 over 23. So therefore, no, QR is not parallel to segment ST. And we have one more theorem called the mid-segment theorem, which says that the segment connecting the midpoints of two sides of a triangle, so that would be this segment, DE, is connecting these two sides of a triangle. How do we know that D and E are the midpoints? Because of these tick marks. These two halves are equal, which means that this is the midpoint. So the segment connecting the midpoints of the two sides of the triangle is parallel to the third side, and it's half as long. So this one is the longer one, and this one is half that length. So we can think of this as x, and this is 2x. So we're going to go both ways. Sometimes they'll give us x, and we'll have to find this length, or sometimes they'll give us the length of AB, and we'll have to cut it in half or divide by 2 to get the length of DE. So you just have to be careful. So find the length of QS. Well, if PT is 10, PT is the bigger one, right? So QS is going to be half of 10, which is 5. Now we can do that because Q and S were both the midpoints. If Q and S were not the midpoints, then we can't use that mid-segment theorem. Same thing, 8 is congruent to 8, so that is a midpoint. And we know 11 is congruent to 11, so that is a midpoint. So that means that I can use the mid-segment theorem. Now 14 is the smaller side, right? So we're not going to divide by 2. We know that this length, Q, is going to be double 14, right? Because this is the bigger side. So 14 times 2 is 28. So that's what Q equals. And that's all for section 7.5.